No, I'll call you on a need-to-know basis.
I love running this company. I love running it because of the people I deal with. There's such a great team of people.
From a career perspective, it's the best move I ever did. I'm enjoying the work. I'm currently on a project and booked for another project soon.
It's given me the opportunity to work with lots of different types of technology and explore some stuff that I maybe only dabbled in at university or before.
SSW is a company that makes enterprise software solutions, and that's what we do. We build software for clients on demand. We build bespoke solutions using the latest technology and the latest best practices.
I've been involved in the development of some mining software, been involved in the development of software for a legal firm, and everything in between there. Even in just under 2 years, I've been working across so many different projects.
We play as hard as we work. You know, it's just a really great place to come into, and I always look forward to coming to work.
So since I've been working here, I've really been pushed, and that's what I wanted. You come to a place where you're working with a team of just absolute weapons. We've got the best in the business here, and that's an exciting place to be.
The guys are very passionate about doing things right the first time. We share our best practices with the community and with our clients and with others. Using conferences, we speak at events, and also we have the SSW rules, which is a huge archive of the best way to do everything.
The management here is totally approachable. So if you have a better way of doing it, or you know of a better method, then everything is up for discussion. As an example, say authentication. So a lot of the guys are building authentication into their apps, and they've been through many different ways of doing that. So generally what ends up happening or coming from that is a discussion around what's the best way of doing it. And we come to a decision based on industry best practice, as well as our own experiences on what the best method and approach is. And that then turns into a rule that we have on our rules.ssw.com.au website.
What really defines this company and make it work is the fact that we have people that are able to share their knowledge and solve complex problems together. It's a wide variety of different clients, different structures, different sizes, different industries, and different technologies as well.
The world we live in now is just so many light years above the world that we were working in even 5 years ago. We get into lots of topics deeply, and it's fascinating how it all works and why it works. You know, we get paid to make fancy jigsaw puzzles.
Access granted.
Developing software is a unique opportunity to be creative and technical at the same time. It gives you the opportunity to solve problems. It gives you the opportunity to exercise and flex your mental muscles by solving problems and figuring things out, while also being creative.
You can feel that energy when you come into the office. There's a really good vibe and connection between everybody who works together here. It's really collaborative, and we even have the tools for doing that collaboration now as well through Microsoft Teams. We always try and team up in pairs where possible for client work. 2 heads are always better than one.
I believe being a developer, a good developer, is writing good quality code. But being a great consultant, which we are at SSW, is half-half between technical skills and communication. That's what makes us different on the market. That's what gives us our edge, because we're capable of not only doing great work in terms of technical skills, but also bringing value and bringing our insight based on our experience, saying, oh, to solve this problem, I would recommend you going that way or this way. And bringing that value, that strategic value to a client, and being able to phrase it, not only having it in your head, but phrasing it to give them options.
And we make sure that people are communicating internally with each other in a way that is professional and succinct, and we make sure that that's the way that we communicate with our customers as well.
And I want to show you a few ways that make email a more useful.
People that want to improve their communication through public speaking can do that through the conferences that we're involved in. They can do it through SSW TV.
You might actually not need to go native, guys.
We have a lot of videos that kind of help get your face out there, to get your name out there. We also have a really good social media presence. We have a great marketing team that takes care of that.
We are client-facing all the time. There's no way to work at SSW and just be behind the desk and not talk to anyone. Every day you have to communicate. So that brings communication as a core skill of what you've become. And some people develop it a way further, like by doing public speaking. We have awesome speakers. I think NDC videos prove that. We have awesome tech tips and even conferences given by SSW people. I think we had like 6 or 7 this year, so that's pretty huge.
One of the exciting things about working here is we're always on the bleeding edge of technology. We're always trying to reach out to those new projects. What are other people doing? What's the next best thing? I think Adam being a Microsoft Regional Director really gives us a bit of an edge in that regard as well, because he usually knows what's in the pipeline before other people do.
We've had many younger guys come through SSW, and in a few short years, they've become absolutely amazing developers.
You can have guys with just a few years of experience and they're building software that's affecting tens of thousands of users with some guidance of the software architects. It just works. Like, it's amazing. You build something and you test it that you can enter an order, and then all of a sudden you can enter thousands of orders like in seconds. It's just incredible. We couldn't do that a few years ago.
We have a couple of different ways that we socialise. Every lunchtime, we're killing each other in board games, which is always good.
It's interesting because those games, are about psychology. That's very interesting. You learn a lot about people.
The most exciting thing that we do is obviously our company retreats. We go away for a weekend after doing a brainstorming session. On the Friday, we all work together as a group and work out, problems for the company itself. We always try and keep the activities a little bit different to make it a bit of fun.
It's just a great weekend all around.
People that come to work here want to be at that level of globally recognized expertise that some of the best guys at SSW are at. And even if you're not at that stage now, I think that a lot of people that come to work here are inspired by that.
A lot of clients come to us with maybe a general idea of what they want. And you can use your expertise and past experience to really inform their decisions and make sure that they're developing the best possible product. I really enjoy that part of it. I think that would be very satisfying for anyone who's been working on maintaining an old piece of software or maintaining an old system. If they could come and maybe work on some new greenfields projects and potentially, influence the way that product comes out at the other end.
You can come up with cool designs, you can come up with new solutions, you can come up with elegant ways of solving problems that haven't really been done before, and plus you get to build something. And often the projects that we're engaged with, you get to build something that's going to make a difference.
People want more stuff automated, they want richer interfaces, they want bot interfaces. The architecture keeps expanding, the knowledge of Azure keeps growing. Like, I'm still learning. I'm still trying to get better. I'm still trying to make solutions quicker, more maintainable, cheaper, and there's a long way to go.
go-kart. Now this is my red shell. I'm bumping everyone. Yeah, money. Go free! Go John! I feel like Adam's true competitive personality only comes out on retreats. Like we go on a bush walk, or we play tennis, or we go swimming, or we go go-karting, and all of a sudden he's just like, get out of the way!
Thank you very much for coming in, guys. I hope you all enjoyed your rides today, and I hope we see you all again, guys.
To SSW.
Coming up this month, personalized ChatGPTs. OpenAI releases a GPT-4 that is super powerful, and GitHub gives us a transformative experience you'll want to see. I'm Adam Kogan. Let's get into it. All right, welcome to the SSW Tech News. Let's get into it. The first piece of news we have is a session coming up called Evolving the Building Blocks of Your Codebase as You Scale. And this is by Alix Klingenberg, and she is involved in running the Server at Scale team at Octopus. Now, Octopus Deploy run very large projects, and they care about scale. She's going to be talking all about that, and I think you'll find that fascinating. Now, the first piece of tech news came from the keynote of OpenAI, where Sam Altman gave us so much news, but one of the things was how that they have released a whole bunch of these customized ChatGPTs, and there's so many of these. If you've got a problem with your laundry, you can use the Laundry Buddy. There's tech advisors, there's game time, there's so many of these. Unfortunately, there's been a whole bunch of little startups that have based their startup on the OpenAI services, and now they're out of business. A big shame there. And how do you build this? Well, you build this just without any code. In fact, I should mention, if you went back to, say, SSW here, we even built one ourselves. If you go to Rules and you go to Rules GPT, we spent many, many weeks building this Rules GPT, and it will answer any question that you want. But we don't need to write code anymore to build a solution like that. You could build it in here, and you would have a nice little solution built very quickly. So it's pretty awesome. And it accepts images and does a lot more than it used to do. Now, they also mentioned how the OpenAI services got really powerful. So we have GPT-4 used to support 2K, now supports 128K. So way more powerful, can accept a lot more text, and also images, etc. Next piece of news. The data that we were using when we asked ChatGPT was back in 2021, so it was over 2 years old. It is now current, so it's almost current, up to April 2023. So if you wanted to ask who was the US president at the in beginning of 2023, you'll get an answer now. So and also you've got the browser add-in, so you can get up-to-date answers. Next piece of news. This was a huge conference, the Universe 2023, all GitHub, and they talk Copilot. You'll see a nice little infographic here. But if you're using the mobile app, you will have GitHub Copilot chat. So you'll be able to find a GitHub issue or find some code, get assistance on a pull request. It's going to be a really nice experience. In addition, we've been using Copilot with Visual Studio and VS Code. They now have one for Writer in beta, and you can use the same experience in the browser. They've given a lot of information here. You can look at some of the videos and get a very quick idea of it. I'll just show you. So let's have a look at what this video is. Okay, so this guy is looking at this regex and goes, what the hell is this? Regexes are often considered a solution for a problem that doesn't exist. Anyway, this developer, let's just say he hasn't written it, he wants to know what it says. Over on the right, you'll see this little guy. So let's just see what happens here. He clicks on the little guy and says, explain that code. It pops open and says, sure, this is what I understand. This regex does this, and this regex does this, and this regex does this. And that's pretty awesome. That is really good at explaining code. So let's look at, I think they've got a couple of other videos here. And I would say, let's have a look at this. So here we've got some code, and you'll notice he's going to click on this little gadget, Now this code, what does this code do? It looks like it grabs some data and it probably just renders it in the browser. So there it is. Oh, whoa, what was that? You might see, if we step back a bit, he clicks on apps, and under apps, there's a whole bunch of different services in there. One of them might be data stacks, or Launch Darkly, Postman, and this is now going to say, how's this query performing? And they do a whole lot of performance, the performance of the query varies, et cetera, et cetera. So it's giving a whole lot of information. Then it says, well, how do I improve it? And it will then say, this is what you need to do. Create an index, use prepared statements, etc. So all fascinating stuff. I'll play the rest of this. And you can go into apps, and now we're using Launch Darkly. So what do we? So Launch Darkly is a service that you put in your code, and you have feature toggles, and you can do A/B testing. And is this flag enabled in production? So I selected some code, and it's going to look up what's in production, and it says it's partially enabled for 20% of the users. And now you can use it for Postman, and you get the idea. You can start integrating your code with all these services while you're writing code. So very, very cool. Let's look at the other ones. There's this one too. I will play that. So here we have a pull request. Some code's been written, and automatically, without even being asked, some GitHub Advanced Security bot said, I found some problems. So you go, wow, what are the problems? Well, it explains what the problems are and says, do you want to dismiss what I found, or do you want to commit it? See that commit fix? So maybe we might just say, well, yeah, I think it knows what it's talking about. I'll take commit, thank you. Commit. And merge the pull request, and you're good to go. That's pretty awesome. Would you want your developers developing without a tool like that? You can, and obviously that's why you choose the Advanced Security subscription. Let's have a look at this guy. Okay, now, so what are we looking at here? We're looking at a GitHub issue. So someone's opened something here. All right, so I would consider this a simple issue with a little bit of information here and an image. Oh, and the image has an arrow saying the GitHub handle should go here. So I've seen better GitHub issues than this, but it's okay, so you could work with that.
So we created an AI native workflow that dramatically simplifies the way you use natural language to turn these great ideas into code. We call it the Copilot Workspace. Starting with any GitHub issue, Copilot Workspace automatically proposes a solution.
Right. So let's have a look at this. It is, it's got the topic about the GitHub handle missing on that image. And then it's saying automatically, this is what I'm identifying, that the contributor does not display the handle. This component is rendering this. There's no stylized component. The issue is this. So this is what it identifies that it sees. And this is what it's identifying that it's proposing that it would change. So if it guesses it right or understands it correctly, you can just take it. So
automatically proposes a solution based on its deep understanding of the code base, issue replies, linked tasks, everything.
Now, what if it almost got it right? What would you do then? Well, let's have a look.
Copilot Workspace then builds a step-by-step plan to implement the changes so that you know exactly what needs to be done. And if something isn't quite right, the spec...
See? So they've gone in to edit it, and they'll make any changes that it didn't quite get.
And plan are fully editable, so you can easily steer Copilot in the right direction. Once you're happy with the plan, simply click Implement and let Copilot chase down the necessary changes across your entire repository. And beyond simply synthesizing code...
Is that scary? That it said what it could see, said what it's going to do, and then showed you the code it's going to make?
Copilot Workspace builds and tests the changes and validates that they're successful.
Oh, no, get a load of that. Now, just before it just before you say create pull request, you can run it and just check that it's all working nicely.
That they're successful. It will even run your code.
Now look at this. So it's run it and it's checked it's all okay, and there's a little browser thing here. So you can click that to see what it looks like when it runs in the browser.
Find the fix visually. This looks great. Since the workspace is designed for collaboration, you can edit any of the suggested changes. And if you accidentally introduce an error along the way, Copilot will automatically catch it, repair it, and rerun the code. Once the issue is fixed, it's easy to create a pull request with a generated summary of your work. This lets your team review, merge, and deploy faster than ever. We're building Copilot Workspace so you can turn your creativity into reality every single day.
I've been doing this for a long time. I've never seen a demo like that. That is out of control. Anyway, you can get a good handle on that. I don't think you should be having any developers not trying to get abreast of this. Next piece of news. Well, nothing will be as good as that. Let's move on to this. This is Next.js. Now, we're using Next.js on many of our sites. We're on Next.js 13. So 14 is coming, and I guess the most important thing is you see it's 53% faster local server startup and 94% faster on code updates with fast refresh. So look, there's a whole chunk of other stuff, but that's enough for me to say go with it. Next piece of news. This is Aussie news. We're very excited about this. Microsoft is already, the default cloud for Australian government, which we work in. Obviously, that's awesome. They are now committed to spend another $3 billion in Australia. And what they basically says is they've got 20 data centers. They're moving to 29 data centers. So that should be awesome. Now, let's look at the next piece of news. For all those Apple MacBook enthusiasts, then we've gone from M2 to M3. Awesome. Next. Now, I think this is really important. When you have an image, you need to know if it was AI generated. They're going to have these invisible watermarks, so you'll be able to tell. I think that's really important. The same with videos. If they've been touched, I think we need to make sure that there is something in it to say this is not a genuine video. Otherwise, we're not going to know what truth is and what it isn't. Next one. Oh my goodness. Elon Musk has announced that he has a new AI chatbot like ChatGPT, but he's going to say it's more humorous. Now, of course, as usual, he announces this well before there is anything. He's very keen on it. If you're reading his tweets, there's a lot of crazy tweets he does. He says that his AI chatbot called Grok will be sarcastic and humorous. Yeah, he said it's going to answer spicy questions that all other systems would reject. Okay, good. And then to demo it, he asks for a step-by-step guide to making cocaine. Is this nuts? And it responds, just a moment while I pull out the recipe because I'm totally going to help you with that. And then, cannot believe this. And then it lists some generalized rather than useful information combined with some sarcastic suggestions before warning against pursuing the idea. Okay. All right. Okay. Anyway, on to other similar things. We have Google investing $2 billion into Anthropic, and that is a rival to OpenAI. So that's great news that there is more and more of these. You should probably sign up for Claude, which comes from Anthropic. Okay, so that is another one to check. So you got Claude, Bart, OpenAI, and the Chinese ones. And obviously the AI stuff is getting scary and we've got a few wars going on in the world. The US and China, this is great news, that they get together and they talk about the fact that we will not use AI technology in autonomous weaponry. Okay, I'm glad that they're speaking, so that's good. All right, Midjourney, they will be releasing some mobile app, which is much better than using Discord, so that's great news. And what have we got here? Baidu. Baidu is the Google of China. They do a lot of cool stuff. There's a lot of big clouds in China. Tencent is enormous. And there's AliCloud as well. And they're all producing AIs. This Baidu's one says the Ernie AI is not inferior in any aspect to GPT. So that's good. So actually, I'm heading to China at the end of this week. I'll report back. And what's my last piece of news here? Oh, Ignite. Yeah, Ignite is coming up. So we've had some big conferences from GitHub and OpenAI. Now we're going to get one from Microsoft, and we'll find out what they've been doing and what's new. So that should be very exciting. We'll be talking about that next month. Hopefully you found that useful. If you have any questions, throw it down there in the comments. If I missed any questions, also throw it down there in the comments. Enjoy the user group coming up. We have heaps and heaps of videos on our channel. Go and see them. I think that you'll find lots of cool tech for Microsoft developers. And until next time, this is Adam Kogan signing off for SSW TV.
All right, hi everyone. My name's Alex. I'm here to talk to you about how at Octopus Deploy we've been evolving our code base as we scale. I don't think it's going to be quite as exciting as some of the AI content in the news, but we'll give it a go. We'll see how we go. So my name's Alex. I'm a senior software engineer at Octopus Deploy. I work in a team called Server at Scale. This is relevant because my team is tasked with taking what Octopus Deploy has now and really scaling it out for our enterprise customers. We've got a bunch of stuff to get through tonight, so I've made us a bit of a roadmap. Essentially, this is going to be a tour of some of the problems that my team have encountered as we try to scale up, how we've solved them, and what we've kind of learned from them. So we're going to start off with a little bit about what I mean by trying to scale Octopus out and what Octopus Deploy does. So as a company, we were founded in 2012. It was quite a while back now. As you can imagine, the landscape of deployments and the complexity of deployments has changed a lot in this time. We've done about 150 million deployments to date. We've got about 600,000 machines that are using our little agent. We call it a tentacle, Octopus tentacles. And we've got some really cool customers. I don't think they're on the slide, but when I found out that Blizzard were one of our customers, I had an absolute fangirl moment. So that is very cool, and I mention it at every available opportunity. So we do cloud deployments at scale. What we are working with is enterprise companies who have just absolutely massive scale. So looking at these kind of things, these are the concurrent numbers that we're trying to hit. This is usually within a 24-hour period. Something like 16,000 targets. The deployment target is essentially your infrastructure that we are deploying to. So your VM, your container service, whatever you want. So one of the sort of fun things for me about Octopus Deploy in particular is that the kind of problems of scale there are quite different than problems that I have previously encountered. The kind of software that does deployments is kind of a different beat from the kind of web app stuff that I had. It's essentially a problem of coordinating a lot of different complex interactions with all of these targets and making decisions based on those interactions, right? So it's not a particularly user-heavy flow. So one of the other super fun things that we do is, because our value proposition is basically, we will run arbitrary scripts on your infrastructure securely, compliantly, reliably, auditably, in whatever sort of regulatory environment that you need. A lot of our customers choose to self-host Octopus Deploy. And so what that means is that while we have cloud offering, whatever we build also has to be able to be run by our customers on their infrastructure, usually in the cloud environment of their choice. But it means that we are explicitly not cloud native. So to solve these problems, we can't use fancy cloud stuff because we can't ask our customers to run a service bus for us. We can't ask them to do a lot of stuff. So at the end of the day, really just our application, our database, and all of our little remote agents running on the infrastructure. When we talk about core problems, I'm not talking about bugs, right? I'm not talking about stuff where we made a whoopsie, you know? I'm talking about the kind of emergent properties that happen when you have your software used more and more and more, and you see the ways that it's going to creep under that kind of strain. Like I mentioned before, like a CRUD-style app, like a typical web app that's very user-oriented, CRUD in terms of like create, read, update, delete kind of operations, the performance characteristics of those are very different from the performance characteristics of deployments. In particular, it's really, really bursty. So you kick off a deployment to all three of your environments. That's going to fan out into a lot of different tasks for a lot of different things. So the nature of that work can be that it scales up really quickly. And again, we're coordinating all of those multiple agents. Those things aren't necessarily running on our infrastructure. They're running on our customers' infrastructure. And it's not always a nice cloud environment either. It's pretty frequently active devices out in the real world. Examples are medical devices, devices in hospitality, even car washes, actually. And so coordinating this kind of remote work in these kind of constraints, especially though we can't use cloud technology, it's a fun problem. I'm going to talk a little bit about how the concurrency concept plays into our scale problems. So, when we're talking about complexity, we often talk about complexity in software, and we're often talking about it as accidental complexity. We built something, but the way that we built it is harder than it needs to be. Maybe we planned for scale that we didn't need. Maybe we tried to solve problems that we didn't have, but someone in the team had at their past job. What I want to talk about here is the essential complexity of the type of deployment software that we deal with, which is that ability to deal with input from a lot of different things in a range of conditions and still come up with the correct behavior. So correctness is absolutely key for us. We had an incident recently. This was, I wanted to talk about it. It doesn't quite fit in because it was actually the result of a stupid decision. But one of our customers was on the call with us. We were trying to ascertain at that point whether we were actually doing things incorrectly or if we were just kind of logging things out of order. The customer said to us, hey, look, we do blue-green deployments, and we think that this execution is happening out of order. We are really, really worried because in a blue-green deployment, you bring up your new infrastructure, you start running your traffic through it, and then you bring down your old one. And he said, if you bring down the old infrastructure without having successfully brought up the new one, there will be no bank. Okay? There is no bank. And so the thing that just echoes in my mind whenever I think about the importance of correctness is there will be no bank. And so that correctness and the complexity is basically essential. That is what you are paying us to solve for you. And so it is kind of a domain modeling problem because that is what we're here to do. So I'm going to introduce you to this guy. This is essentially one of the things we use in our code base to make it easier for our developers to think about how a lot of this complex diversity work gets done. I'm going to introduce it now because I've been referred to it a bunch, and so I want to, so hopefully, you'll have a bit more context around what I'm saying. Essentially, the ServerTask thing is an interface in C# language, but it provides developers with a whole lot of stuff for free. So it is an item that can be viewed. It is essentially a wrapper. Uh-oh. Let me try that a bit closer to the mic. It's a wrapper around an arbitrary bit of work that allows us to queue and control how many things that are executing concurrently. And we have some spectacular stories about what happens when you don't control the number of things that are executing concurrently. But this is just something that, in general, people use that the developer can go on to focus on whatever fancy functionality that they're building. And in particular, my team, this has become like our best buddy as we've been working on this thing and trying to get this particular part of our code base to scale. I'm going to be talking about concurrency as well. Concurrency is just the idea that multiple things are executing at the same time. Concurrency isn't really a bad thing by itself, right? It's just a concept. There are multiple ways concurrency can go wrong. And this time, happily, this is not a deadlock problem. I've dealt with deadlock problems, those are not fun either. But we're specifically talking about the kind of race condition problem that happens with concurrency. So we've got this beautiful little diagram that our design team made. What you can see is, looking at thread 1 and thread 2, generally concurrency is going to show up because multiple threads read the same item from the database, they mutate it based on whatever they're trying to do at the time, and they write it back. But what you can see in the example, right, is thread 1 writes before thread 2 does. This means that whatever thread 2 has done to that object, it's likely incorrect because it is missing any changes that thread 1 did. The delightful thing about race conditions is that these are really hard to identify, right? This doesn't necessarily result in an error at the point that this kind of out of order execution happens. This results in an error somewhere down the path because your data is inconsistent or incorrect. It's basically the problem that the result of whatever you're executing isn't actually deterministic, right? Like, it depends on the timing. And that can be really hard to replicate because you don't necessarily know, because remember, you don't see the problem until way down the path. You don't necessarily know at what point you had some sort of timing problem. So generally, the best thing you can do is avoid it, right? And there are lots of tools and techniques and stuff that people use to avoid getting in the problem in the first place. But as always, there are a bunch of trade-offs to consider as to what we're going to do and why. So what I really want to talk you through here, going through some specific examples, is the trade-offs that we chose to make, and then essentially the ways that they bit us in the ass a little bit down the road. So we're going to talk about problem number 1, cluster-wide mutex. We're going to talk about the concept of pessimistic concurrency and how we modeled that in our database. So cluster-wide mutex. You'll remember before I said Octopus server, we have the database, we've got an app, that's it. In order to get more throughput, in order for us to be able to execute multiple things concurrently, we offer our customers the option to run Octopus in what we call high availability mode. It's horizontal scaling. The cluster-wide mutex is an application level concern that we built to control which nodes in a cluster are executing something in particular, or have essentially like a mutation lock on something. We chose to model it in the database because remember, that is the only shared resource that we have between the multiple nodes of the cluster. Theoretically, we could communicate in between them. But there are some failure modes with that that made the database one a little bit better. A little bit better choice for us at this point. And while I was sort of researching for this talk, I found out, I must have learned this at uni and completely forgotten, but mutex actually stands for mutual exclusion. Essentially, it's the idea that when you hold the mutex, you are excluding anything else from mutating that object. with mutex has nothing to do with mutation, which was wild to me. So, how did the cluster-wide mutex fail? Well, one of our customers came to us, and this is a customer who self-hosts. And they said to us, hey guys, the database failed over. What did you do? And we said, that is a great question. We don't know. And they sent us through a bunch of data. So one of the things that was immediately notable to us was that this had happened after a 10-day long deployment. This is one of the fun things about enterprise deployments. If a customer says their deployments take 10 days long, then like that is not our place to argue with them. Sure they do. Great. So what happened? What we found was the database had failed over because it had run out of disk space. It had run out of disk space because the transaction log had eaten all the disk. What had happened was this, that cluster-wide mutex, that was implemented by opening a transaction in the database for the duration of the deployment. After 10 days, the transaction log in SQL Server is essentially like SQL Server's working space, right? And to be clear, sorry, this is only SQL Server. I do not know about this behavior in Postgres or anything else. Specifically, SQL Server is what we use. So transaction log is basically its working memory. As it makes changes, as you connect to it and update things, whatever, it adds into the transaction log and uses that to apply to the actual database. It's an internal concern, and so SQL Server will clean it up over time. It'll essentially garbage collect it. It will not clean up the transaction log while you have an open transaction. Fair enough, it can't really make a reasonable decision about what's safe to remove. So we had essentially stopped it from cleaning this thing up, and after 10 days, that was enough that the database just gave up and died. So what we had done was we had used pessimistic concurrency. Pessimistic concurrency controls are a control where you ensure that you have the ability to mutate an object before you try to do it. So something like a mutex is a pessimistic concurrency control. You're pessimistic because you want proof before you try to do the thing. You don't really think it's going to go that great. When we built the cluster-wide mutex, we modeled it as essentially taking a lock on a row in the database that represented that server task, where that server task represented a deployment. And the thing that was really nice about this for us was when you're building these kind of, I guess like shared application level things, you really want to be thinking about the failure modes. And the failure modes of a transaction-based mutex were that if a server node went down, we all know it's going to happen, it would behave the way developers already understand a transaction behaves. The SQL Server connection will die, and the transaction will be rolled back. The changes will not be applied, and eventually, that hold on that resource in the database will fall open when it dies. And so this was great. This kind of gave us what we wanted, and it was something that we all kind of understood how to work with. So this is what the code looked like. This is literally a screenshot from my IDE today. We grab the mutex. As you can see, if you know C#, it's an idisposable, and then we do the thing. Basically, we do the thing that's going to mutate the object. If you've been writing software for a while, you may immediately see the problem with this, which is that you have to rely on a developer to remember to write that first line to take out the mutex before you mutate the thing. Using a language like C#, obviously, I am a huge fangirl of C#, you do get a lot of sort of nice code analysis properties, right? Like you can see where an object is used. You can understand where the updates happen to it. But even then, you can't really use code analysis tools to tell you where something is mutated if you want to like defensively protect against developers trying to mutate something without taking out the mutex, because of our buddy raw SQL. And we'll talk about that a little bit past line. So essentially, the whole exclusion, this control, requires developers to remember to put this line first. That was not a great outcome. We decided, look, this thing is going to fall over in 10-day long deployments. And when we looked at it, we found that it was not being used consistently. There were places that did not respect the mutex. And if somewhere doesn't respect the mutex, then basically you're fucked, because anything can mutate it. And it's very hard for us to protect against that, essentially. So we decided, look, we're just going to take this thing out, and we're going to solve this problem in another way. So, great, problem 1 solved. That is wonderful. Let's talk about problem 2 and our next foray into pessimistic concurrency. This one, so that first story, I was deeply involved in that one, in the weeds. This one is more of a theory as to what happened. So if any of you can actually listen to this and tell me what you think went wrong here, I would love to hear it, because I'm still not entirely sure. The same customer came to us and they said, hey guys, the database failed over. What did you do? And we went, we fixed that. What do you mean the database failed over? Was there anything different this time? They said, oh, well, now that you mention it, actually, in this case, it wasn't the transaction log that filled up and caused the database to fail over. This time, it was the temp DB. All right, so it is another problem. Delightfully, this is what happens when you scale. You fix one problem, and one more 10-day long deployment later, you find the next one, the next point of failure. And so it's very satisfying that we had fixed the other one. So this one, halibut. You will have noticed Octopus loves a fish pun. Halibut is essentially a custom RPC protocol that we wrote to communicate between Octopus server and our deployment targets. That's a lot of jargon. Let me break it down a little bit. So you'll remember Octopus server, the node that runs the deployments, that is the brains of the creature. It communicates with our tentacles. Those are the agents that run on the machine. You can see it in this diagram, right? So we've got the node, we've got the remote agents with the tentacles running on them. Halibut is the name that we have for the custom communication protocol. RPC means remote procedure call. Details are not super important here. It is just a common machine-to-machine kind of protocol. And so this one we did actually model in the DB a little bit as well. But what we were trying to do was, when we are deploying to a particular target, basically every deployment is a lot of fancy and very useful and important wrapper around an arbitrary script. At the end of the day, it's just a script. And so we take a lock on the deployment target to stop us from running multiple scripts on this deployment target at the same time. No one wants to start cleaning up the packages for your brand new deployment before we actually start running it, right? So this one was a little bit different in the sense that we weren't trying to stop the specific problem of concurrent database updates. We were essentially trying to control the behavior of not executing multiple things over on our remote target. And the failure for this one actually happened inside Halibut, inside that network communication layer. So what we did, we had another style of mutex where we modeled our exclusion hold on the remote target with a transaction in the database. But in this time, we were actually also using the isolation level of the transaction. So you may be familiar with database transactions where when you create one, you can say, I'm going to stop everyone else from reading this thing while I have the transaction open, writing to this thing, some mix of the two. So in this case, we essentially use those to give ourselves a little bit of flexibility around who, oh cool, I just messed up my earring, great. Anyway, let's get back to databases. So we used this to essentially give us a slightly more fine-grained control over how we executed things in tandem, again, using something developers were really familiar with, using database transaction isolation labels. You may also be familiar, and I have to admit, I don't know if this is a pure SQL thing. At Octopus, we hand-rolled our own communication protocol. We also hand-rolled our own ORM, our own object relational mapper. That is a whole story. There is an excellent blog post about it by our CEO. It's called Nevermore, not for the reason that you think it might be. But anyway, you should totally go read that. It is amazing. Anyway, point is, in the ORM, we can set a timeout on a transaction. And we did set a timeout on this transaction that was being held, essentially by the communication layer, actually, on this target while we tried to run a script on it. And we sent it to int max by default. Turns out to be about 16 days. So about 6 days longer than our software can survive a deployment at this stage. So what happened essentially was there was a communication failure, but because we weren't sort of modeling it in a way that if that failed, it failed open, this failed closed. The communication failure happened after about 2 days. Again, remember, same customer, 10-day long deployments. I don't know what they're doing. It happened after about 2 days, and we just held on to it, and we would have continued holding on to it for about 16 days until it actually timed out. I'm not sure exactly how that got around to filling up the tempDB. This is the part that if anyone knows, please tell me. The tempDB is another internal SQL Server concern. So SQL Server, if you are, for example, making a temporary table or assigning a variable or something like that, it stores that data in its tempDB. I have a feeling that what happened here was that after 2 days, this communication thing failed, and so the deployment just hung. And the customers didn't necessarily notice because they were used to it taking a long time. And I suspect that somewhere we were just backing up all of the other things that we wanted to do to this deployment target that we couldn't do because we were waiting on this one small step. And so I assume that's sort of how it ended up blowing up. But this was a case where pessimistic concurrency failed us, essentially because the way that we had modeled this one failed closed, not open. So yeah, in this case, again, not a database update. The fix that we did for this one was really different. And this is one of the things that I really love about working in the server at scale team, is that we have a remit to touch whatever we need. So while we weren't able to pinpoint exactly what went wrong such that the database failed over, what we ended up doing was we decided this would be addressed, and as far as I know, it has been addressed by some changes that we were making to Halibut, such that we identified network errors. We identified them before things timed out, and we retried them. That involved a lot of work in making our tentacle idempotent, essentially saying that if we were to retry something, it will have the same impact. It won't be a problem if, for instance, we were to run the same script twice. And so, as far as we know, that one has actually fixed it, which is not a very satisfying conclusion, unfortunately, but it is the one that we have. So let's talk a little bit about, more about what I mentioned before, very briefly, this idea of hung deployments, and then the point at which we gave up on pessimistic concurrency and decided to embrace the promise of optimistic concurrency instead. So this one has even less data to back it than the last one. This is an anecdotal customer problem. They call us up and they say, hey guys, the deployment is doing nothing. It has hung. It has been in one state for the last 3 days. No, it's not something that we did. It's something that you did. Anecdotal problems are very hard to fix. And again, often this is happening in customers who are running our software themselves, we don't have telemetry, we don't have error logging, we don't have access to much at all. And in fact, even in our cloud environment, things are incredibly, incredibly locked down, because I'm sure you all can imagine exactly how sensitive access to your deployment processes and your secure variables and secrets and stuff in there is. So this anecdotal problem was essentially, hey, deployment gets stuck, will not progress. This brings us back to our buddy, the ServerTask. So the bursty nature of the software is such that when we are doing all these arbitrary bits of work, whether we're picking up all of the packages, whether we are starting to deploy out the different releases to the different targets, we tend to have a hierarchical model of the work that needs to be done. Essentially, for a deployment, if that deployment is, for example, to a single environment, to multiple tenants within a single environment, it all rolls up into a single server task. And that server task has to be the entity where we represent the overall state of all of these complex things, with all of the multiple ways that things can fail and sort of fail and maybe wait for a bit. And so we were getting race conditions in the server task. So similar to our beautiful initial race condition, deployments would complete. One would update the state. But looking at this, for example, if you imagine thread 1 having changed the state, thread 2 could absolutely overwrite that. And in fact, here is a diagram that is meant to represent this. What we found was happening was that the state would get corrupted. Let me talk you through this diagram a little bit, because it's not as clear as I wanted it to be, but this is hard. So we've got a deployment. In the middle, you can see there's that server task. That's essentially the guy that knows about the overall success and failure and everything in between of our deployment. And you've got M1 and M2. Imagine those are machine 1 and machine 2. Those are our deployment targets. So as they kick off, they pick up the original server task state. Let's pretend that it has a state of in progress. We're going to say machine 2 fails. The state is set to fail. And we go ahead and we write that to the database. But very little time later, machine 1 successfully completes its deployment onto that machine, and it writes it down, and voila, our server task now looks like it's succeeded, even though one of the machines has failed. And there is no sensible way for us to continue from here. So the deployment just sort of hangs around, doesn't do anything. This turned out to be incredibly hard to detect. We wouldn't be sure at which point the state was getting overwritten incorrectly. We weren't sure where it was missing the updates, and it was very, very hard to replicate locally. And so we said, you know what, this whole pessimistic concurrency thing, this is not doing it for us. Let's have a go with optimistic concurrency. Optimistic concurrency is basically YOLO, I'm going to update, you tell me if that's a problem. So we go ahead, we try to, in this case, update the database, and if it fails, that failure bubbles up as an exception all the way back to the calling code, which allows you to handle that failure in your application, in the business logic layer, where you can make sensible decisions about it, right? Where you have all of the context to know what to do. And so in an effort to fix this, we went through absolutely everywhere that we mutated the server task state. Like I said, this is one of the fundamental building blocks of our software. There were a lot. A lot of places. And so we looked at every single one, we audited them. We found all of the places even that it was being updated in raw SQL, where we can't use, for example, like our IDE to tell us that a particular object is getting mutated. And so we figured out how to handle each of those. All right, a little bit early. We figured out how to handle each of those based on what it was doing. And in fact, we were a little worried that there would be a lot of places that we wouldn't be able to sensibly handle a failure. But what we found was there was actually only one place where we had to give up, and it was an API call. And so we made our API return a 409 error, whereas previously it would have quietly overwritten your state. So that was kind of nice. It lasted in production about 6 hours before we found that it was failing a lot of deployments. Do you know what is worse than a hung deployment? It is a failed deployment. So our cloud team saw our deployment failure rate in cloud go right on up. And they said, you guys just released this thing, you know what, we're just going to turn it off. And they were absolutely right that it was on us. And so the way that we had tried to use optimistic concurrency was, if we go back to our diagram, where we've got our 2 different machines and our ServerTask, this is a very common thing that most ORMs do. I assume I've been corrupted by Nevermore at this stage. It will take a row version, which is essentially like a high watermark of changes, right? So when you read in your initial ServerTask state, at the point that you've done your calculations, that you figured out your updates, at the point that you go to write back, if the row version has changed, this fails, right? And so what we were doing was, we're bubbling those failures up, we were handling them, we thought it was going to be great. We had not expected the scale at which this happened. And this was because we had kind of not realized that the ServerTask was stomping on the state so much. If you recall my example, you might be fanning out to, what was our first number, 16,000 targets. There's going to be a lot of concurrency when you're handling that. But if everything is down your happy path, if everything is going green, it's succeeding, these updates aren't going to stomp on each other. It might be a bad update, it might be bad data, but at the end of the day, it's still just updating it to succeed it. Unless you turn on row version, and then it goes, nope, this is bad data, I'm going to throw. And so we found that this was happening a lot more than we had expected to happen. And even with all of the retries and all of the care that we had taken, it still ended up with customer deployments failing, where previously they wouldn't have, right? From the customer's point of view, there was no reason for this to fail. This was all on us. And this was because of the assumptions that we had made about how often this thing was going to get updated and what the behavior would be like when it did. Oh, all right. So, optimistic concurrency was not quite working for us, at least not in that case. And there was actually a pretty good reason for this. Octopus is full of a lot of really, really smart engineers. The principal engineers had written a target architecture for us, which was essentially a description of how we should build software, what we should aim towards in our architecture, and why these things were important. And so my team, when we were looking for a solution to this problem, we had seen the optimistic concurrency section, and we went, heck yeah, that's us. We're gonna do this optimistic concurrency thing. Look, it's right there in the target architecture. We're gonna do it. We ignored the little coda at the bottom that said optimistic concurrency within a well-designed domain object. And that turned out to be really, really important. So let's talk a little bit about domain-driven design. Look, I'm not an expert here. This is something that I'm absolutely learning about. But what I understood from them to say was, sorry, quick aside on what domain-driven design is. Basically the idea that as a software engineer, when you are building out your application, you are thinking about how you design your model according to how the humans think about and speak about that business domain. And you take those ideas and you use them within the code so that your understanding of the code and the way you build the code maps to the human understanding as well. There's a lot more to it, but to me, essentially, that's what it is. And so this kind of raised the question for us of what is a server task? What even is a server task? It isn't a necessary part of the business domain. It had actually become a conglomeration of a bunch of different things. It was a piece of work that is executed. It was an item in a queue. It was the success and failure of a deployment. It was essentially an amalgamation of horror at the end. So one of the other really important concepts that we hadn't applied that well from domain-driven design is that of invariants and aggregates. It took me a while to understand what an invariant is. Most of the, not gonna lie, like 3 different explanations went right over my head. This is the one that helped me understand it, which was essentially that an invariant is any logical rule that has to be obeyed throughout the execution of your program, and it can be communicated to a human, but not to a compiler. So let's take our ServerTask example. Let's take our state. When you are updating a ServerTask, if it has children's ServerTasks, if any of those has failed, then the parent ServerTask state must also be failed. And we can't quite convince our compiler to do this for us. We have to do this in logic. I mean, maybe you're smarter than I am. Maybe you can find a way to do that. Regardless of this, this particular example, this is the idea, right? It is something that you need to enforce within a boundary that isn't necessarily something that you can do sort of automatically, right? You have to write some logic to do it. And so coming back to our idea of these domain entities, these things that represent a human-facing concept, an aggregate is like a bunch of those smushed together. I stole this quote from Martin Fowler, very, very smart software engineer who's written a bunch of great stuff. An aggregate is a basic element of transfer of data storage. So this is the bit that bit us, right? We needed to be making decisions about the state of the server task, and we needed a few different things to be able to understand that. And so the aggregate concept was we had smushed together a bunch of things that didn't need to be together, where actually we should have streamlined our aggregate to only be the things that we needed in order to enforce that invariant within its boundaries, right? The things that sort of need to be updated together. So the solution here was to pull apart the server task, basically. We had a bunch of unrelated entities. I mean, one that is probably something that a lot of you might do by default. But when we were looking at the children tasks of a server task, the way that we modeled it was with a count on the parent server task. So every time a new one kicked off or one completed, we would be updating that count. And along with it, stomping all over the status, right? This was something that we could model in our brave new world of actually having a real relational database instead of a document database stuffed into a single column in SQL Server. This really reduced the number of reasons that we had to update. That was one of the things that we pulled out, right? And the things that we extracted, we were able to remove because we didn't need them to enforce those invariant rules. We could update them independently. So I'm sure the really smart people among you will be listening to this very unsatisfying explanation of how we fixed it eventually and saying, but you didn't fix all of the concurrent updates. You have reduced the likelihood, and that's going to have a combinatorial effect. So it will be, be pretty good. It'll be a good customer experience. But you haven't actually solved this with the changes that you're making. You are absolutely right. And this is kind of the key part for us about scaling and about how we scale. And it is the decisions and the trade-offs we make about the amount of effort that we invest in the solution to fix this thing that is hitting our customers right now. Like, the delightful people saying, hey guys, 10-day-long deployments, please make the database stop falling over. We needed to solve those. We needed to get over that hurdle and let that customer keep deploying, keep building their business. But we were also aware that the way that we had built this and designed this was inherently subject to these problems. So we rebuilt it. This is also deeply, deeply unsatisfying to me personally, because one, it is my sister team doing it. I have not contributed anything to it. But just aside from that, we haven't completed it yet, right? We are working on it, and we are working on these two things in tandem because they both have a lot of value. We have iterated and we've learnt a bunch about things we would do differently, but we're also aware that the fundamental nature and the fundamental scale of what we do has changed. And so we're targeting rebuilds around some of the stuff, while also trying to support our customers and keep growing in the meantime. One of the reasons that this has been really valuable for us is, you may recall that I said that concurrency and correctness are essential complexity for us in this domain, and it's true. And so it means that whenever you are changing how your deployment execution pipeline works, you do it very, very slowly and very, very carefully, and only as little as you can. So ideally, we would have been able to solve this problem a little bit more thoroughly, and we wouldn't have to include this in the things that we're rebuilding. But I like to think of it as like a beautiful, happy future where we probably use something like event sourcing for managing the state of the ServerTask object. But I can't guarantee anything like that. So yeah, sometimes you got to do both. You got to do the annoying toil, but you also have to do it to understand exactly what the problems are, how they can and can't be solved, and to justify the value of investing in this rebuild and being able to support your customers at their current scale, at your current scale, in the meantime. So yeah, any questions? Yes, that was quick.
Question is, why don't you just do stuff reversely?
Sorry?
I mean, why don't you just do stuff reversely? Anyway, it's just a sequence, it's just a task by task. Why don't you just make every task only be aware of what must be happened before that task, but not be aware of what will be happen after that task. So all the tasks is just kind of like watching what is before it. After what must be before it's done, you just do it. So you don't
Yeah.
say like...
No, I think I understand. So you're sort of saying that why are we doing so much in the task that we can't make it small enough that we can kind of interleave them?
No, I mean, if you go back to the slides where you have a parent and you say the parents must be failed if one of their child failed, right? But why would we use structure your task like this way? Like you got parents and you got your child. I don't think, but if you think it in a different way, like there's no parents, there's no son, there is just a task before me. And I execute it just right after all the tasks that must be executed before me, and I execute it. You wouldn't be having the parents as some problem.
So three things on that. One is that these tasks are not entirely independent, right? So the things that we are doing, we have to be able to change the execution of things, change what happens. If, for example, one of them fails, right, we want to stop deploying out to other things. So we still need a way to understand what's going wrong if one thing has gone wrong to stop the execution of other things. In terms of why model it that way, I mean, yeah, that is one of the first things that we pulled up, right? We changed the way we modeled that relationship, where we moved the essentially the foreign key reference onto a server task. It now refers to a parent instead of the parent having that. That was one of the optimistic concurrency things we did. And additionally, that's what I mean about event sourcing. So I don't know if you've heard the term event sourcing, but essentially event sourcing is the idea that you don't really store a property. When you go to look at a property, you compute it through the history of other things. And so that's what I mean when I said it's likely that the answer here in the future is going to be that event sourcing one. Yeah. Any questions from online or?
No questions online?
Excellent. All right. Thank you all so much.